In this video, we'll explain in detail a classic result often associated with Bernoulli. The series 1 plus 1/2 plus 1/3 plus 1/4, and so on, does not sum to a finite number. It grows without bound. We will carefully show why, using a visual grouping method and a simple integral comparison. Let's introduce the series. We call it the harmonic series. It looks like this: 1 plus 1/2 plus 1/3 plus 1/4, and so on. The question is, does this sum approach a finite number, or does it grow without bound? We'll prove it grows without bound. The key idea is to group terms in a clever way. We'll group them as follows. First, the 1, then the 1/2, then the next two terms, 1/3 and 1/4, then the next four terms, from 1/5 to 1/8, then the next 8 terms, from 1/9 to 1/16, and so on, doubling the size of each group. Now, let's estimate each group from below. Look at the group 1/3 plus 1/4. Each term in this group is at least 1/4. There are 2 terms, so the group is at least 2 times 1/4, which equals 1/2. Next, look at the group from 1/5 to 1/8. Every term here is at least 1/8. There are 4 terms, so this group is at least 4 times 1/8, which again equals 1/2. Next, the group from 1/9 to 1/16. Each term is at least 1/16. There are 8 terms, so that group is at least 8 times 1/16, which equals 1/2. So every group after the first 2 is at least 1/2. Now we can compare the harmonic series to a simpler series. We have 1 plus 1/2, then plus at least 1/2, then plus at least 1/2, then plus at least 1/2, and so on. That means the partial sums grow like 1 plus 1/2 plus 1/2 plus 1/2 plus 1/2, and so on. That clearly grows without bound. So the harmonic series does not converge. It diverges. Let's make this even more intuitive with a visual bar diagram. Each bar represents the size of a group. We already showed that each group after the first 2 is at least 1/2. So the total keeps growing by chunks of 1/2 again and again. There is another classic way to see this using calculus called the integral test. We compare the series to the integral of 1 over x. The curve 1 over x decreases slowly. The total area under the curve from 1 to infinity is infinite, so the series also diverges. Let's visualize that. Here is the mathematical comparison. The sum from n equals 1 to infinity of 1 over n is compared to the integral from 1 to infinity of 1 over x. That integral diverges, so the series must diverge. So now we have 2 powerful perspectives. First, the grouping method shows that the series grows by at least 1/2 over and over. Second, the integral test shows that the area under 1 over x from 1 to infinity is infinite. Both explain why the harmonic series diverges. So even though the terms get smaller and smaller, their sum does not settle down. This is one of the most important and surprising results in mathematics. Thanks for watching.
Don't forget to like this video, share it with your friends, and subscribe to Knowledge Station. Thank you for watching.